assessment 17.32. This assessment asks us to give the mechanism of the hypothetical formation of the hemiacetal on screen. Now, in reality, the equilibrium is going to favor the ketone side as opposed to the hemiacetal, but we can still draw a mechanism for how it would form as an intermediate in a later reaction. The reaction is going to start using sulfuric acid and isopropanol will combine to make this protonated isopropanol. That's going to be the acid catalyst for this reaction. We can protonate the carbonyl using that as our acid, and we'll write reversible equilibrium arrows here. That's going to give us this protonated ketone. We can draw a resonance structure that shows that this protonated ketone is very electrophilic at carbon. So we can generate this resonance structure by moving a pair of electrons from the CO pi bond onto oxygen. That gives us a positively charged carbon. Isopropanol will attack this carbocation to give the following. Note that when isopropanol attacked, it brought along its proton, so this oxygen that was part of the isopropanol now has a positive charge. If we look at this intermediate that we formed, you'll note that it's essentially the product, except with this oxygen having a proton attached. And so in our final step, we're going to remove that proton to generate our product, and importantly, our acid catalyst. So the reaction starts using our protonated isopropanol. It finishes with our protonated isopropanol, and it's faster because of the presence of that acid. This is an acid-catalyzed reaction.